Hey thinkers, welcome back to Logic Unlocked. Today's question is not just important, it's a must known both for your coding rounds and your problem solving intuition. We are tackling with Leetcode 53 maximum summary using the famous Kadane's algorithm. This isn't just a DSA question, it's a mindset shift from brute force to elegant linear time logic. Problem statement is like you're given an array of integers, positives, negatives, and along with zeros. And the task is simple. Find the maximum sum of a contiguous subarray. This means we are not allowed to skip elements in between. The elements must be side by side touching. That's where it goes tricky. So, why interviewers love this kind of questions? This question shows how well you can handle edge cases, optimize from brute force, and manage variables like a pro. Like it's asked frequently at Amazon, Google, Microsoft, and even startups because it tests you how you think, how not just how you code. Okay, let's look at the intuition. Imagine scanning the array from left to right. For example, this is an array which is given and maintaining the maximum sum we have seen so far, while constantly deciding should I include this number in my subarray or start a fresh start from here. So that's where Kadane's trick kicks in. So let's go through our notes. So here is my notes. Okay. Yep. So Kadane's algorithm will be helping you. But before getting into that, just look at this brute force approach. We are selecting every possible subarray using two nested loops. Here we have used this two nested loops and we have tried to collect the sum of this. But it takes a lot of time, like big O of n cube. That is a lot of time complexity. So to minimize it, we have gone through another better approach, that is by reducing one loop, that is k loop. We have reduced it k loop and just directly summed up with the arrays which are elements which are present in j loop, which are coming out from the j loop. And it had reduced it to n square, but it is also not that optimal. We can reduce it to big O of n by using Kadane's algorithm. Okay, we start both current sum and maximum sum with the first element, because that way we are ready for all negatives. Then at each step we ask, do I want to start fresh, or from should I continue or extend the existing array? The max function, the max function takes care of that decision, and the edge cases to mention is optional. All negatives, Kadan still works. Large positives and negatives combos still handles. Single element, no problem. So this is what it is. It keeps adding elements until the sum becomes negative. Here we'll be taking maximum to be int min, or we'll be assigning it to the first element of an array, and we'll be assigning sum to be 0. We'll be running a I loop and summing up in I loop itself. Then after summing the elements, whatever the coming we are going across, we'll be adding it. Then we'll be stopping at a point where the sum becomes 0. Okay, the moment it becomes negative or it becomes 0, it will be 0. Okay, because negative can't be, we can't allow negative sums. It will hurt the future sum. Like in negatives, the negative element will be the highest one. Like if minus 2 and minus 5 is there, then minus 2 is greater, right? So it would be a disruptant, like it won't be an optimal. So we choose like that. What if all are negatives? Then Kadans don't work. Like we need to optimize it. I'll be continuing that topic in the next video, but you just look at this code. If sum is greater than maximum, then allow that sum to be in the maximum. And if the current sum becomes negative, then I already said you that you must reset it to be 0 and return the maxi. Hope you have understood this. Here we had minimized it from three loops, that is from brute force approach, three loops to directly one loop. And we have added it and had done here, used, we can also use the maximum function, or directly we can use a if loop. Okay, And here the time complexity would be big O of n and space complexity would be big O of 1. I would be showing you my intuition. Just one. Okay. So this is a deep intuition of Kadane's algorithm. If you're not okay with this, if you want directly code, you can skip this part of the video. It's okay. So here Kadane's algorithm is about finding the maximum sum of any contiguous subarray. Okay. So it can be any numbers, as I have said, negatives, positives, and also it can be zero. Here it works like this. We'll be taking a current sum and also a maximum sum. We'll be going through the I loop, as I have said you. For loop will be considering the indexes 0, 1, 2, 3, and this will be considering the elements. And here suppose minus 2. Observe carefully, we have taken minus 2. It is a negative, right? So reset the sum, current sum to be 0 and continue. Same thing, minus 3 and minus 2. Minus 2 is the big one. Even though minus 2 is the bigger one, we'll be resetting it to be 0 because it is a negative. Next, we'll be going with the 4. That is, 4 is the maximum. Keep it. It had taken the maximum sum as 4. Then minus 1 is come. Then 4 minus 1, that is 3. Then still 3 and 4, if we compare, 4 is the maximum. So keep the 4 as it is. Then upcoming one is minus 2. If we do 3 minus 2, we'll be getting 1. Even though 1 and 4, 4 is the bigger one, keep it as it is. Then as we proceed till 1, 1 is like 1 plus 1, it becomes 2. Then 4 is the bigger one than 2, keep it as it is. Till here, it is a 4 is the highest one. Then when 5 enters into the game, it is a game changer, literally. 5 plus 2 becomes 7, and the 7 becomes a maximum sum. So 4 is less than 7. So when we put a maximum function, it filters and gives us 7. Okay. 7 is greater than 4, obviously. So we have found a new maximum, that is 7. If you go ahead, it is there is a minus 3. 7 minus 3, it becomes 4, but still 4 and 7, that is a 4. 7 is the greater than 4. So still good. Till here we have found maximum. So we'll be considering from here to here. That is minus 4, minus 1, minus 2, 1, comma 5. These all are the uh, array numbers which from where we have found the maximum sum. So this gives the best sum. So if we add all these things, we'll be getting sum as 7. So here we can see that minus 2 or minus 3 at the beginning, they are negative. So we did not consider them. We have put again to, we have reset maximum sum to 0. So you must notice that. What if all the elements are negative? So we just modified this. If all the numbers are negative, we'd be taking from index 0, that is minus 5, then going to minus 3. Like it will be checking, this loop will be checking and it will be comparing the max. So simply we'll be getting minus 1 is the maximum. That's it. We'll be getting, obviously we'll be getting, it will be returning because max function is about returning. Either we extend the current sum or we start a fresh one. If adding it hurts, which either gives, both gives the same thing. So as I have told this thing, you can see it here. The very like only one loop. So this is big O of n. It takes and big O of one space it would be taking. Let's quickly run this. It gives us if sum is less than 0, it gives, it resets. Otherwise, it will be assigning the same value. Okay. Okay. All right. So it's about a small takeaway from this is this question is core DSA material. If you understand this, you understand dynamic programming spirit. This logic evolves into 2D versions, circular arrays, and more. So before you move on to master Kadans like second nature, and if you ever freeze during this interview, remember you just need to think: do I build from the past or start from here? That's Kadans. Okay. If this helped you, drop a comment down, and don't forget to subscribe to Logic Unlocked for more smart code breakdowns. Let's keep unlocking logic and one question at one time. Thank you so much.